We'd like to invite Cluster Imaging to the stage.
Hello, my name is Semyon Nisenson. I am CEO of Cluster Imaging. I would like to thank the team who helped us. They was a great help, and I really appreciate it. I am a mathematician by trade with a background of theoretical physics. And I developed in 81, 82, first surface modeling package using non-uniform rational B-splines. Then I did visualization product for this, and it was a main product for the company called computer vision for a number of years. Then I switched to computer graphics and image processing, worked for Sun, ARM, a number of startups. I always interested to be in cutting edge of technology. And now I am fascinated with autonomous driving. This is a very big topic. And what autonomous driving requires is a fast and accurate computation of data and distances. Market is huge. The current favorite on this autonomous driving are Lidar technology. There are around 46 Lidar companies, and a number of them raise over $100 million. People say that is Lidar bubble. But now cameras become new technology which I believe would be replace LiDARs. They're much cheaper, and the problem of cameras is quality of distance measurement and also number of computations could be performed to get this. So what our company is doing is generate accurate 3D data. And we are much cheaper. You've seen these vehicles on the streets with big LiDARs around, driving all streets, and they're expensive. And the main challenge of cameras is provide to requirements automotive needs, which is a distance range. We're doing from 50 centimeters to 250 meters. Also, it requires high definition. And this is also important because you want to see small things on the road, like broken tire, or people in front of you driving truck with pipe sticking out. These things cannot be picked up by LiDAR. They have very low resolution compared to high-quality imaging. Now, about frame rate. It's also important. Cars are moving very fast. So you cannot do 20 frames per second. You need to do 60 frames per second and preferably even higher. But current technology, we are talking about 60 frames per second. And how we achieve this? We get fundamental algorithm. I'm a mathematician, so I do algorithm and patterns. And 3 patterns which enable us to do quality work. Here is the illustration, which is we shot a few months ago in Mountain View, no, in Sunnyvale sequence, and blue is in closer, red is farther. So that's typical big street. And now you will see the depth map. the distances. So you actually see objects much in better shape than in LiDARs. And you see edges definitions, which good for identify objects. And that's what we do, real depth for the images. This is our previous prototype we did for DSLR, we did for mobile, but now we're concentrating on automotive. And that was the quality of depth maps we were producing for DSLR. This is illustration how models could work. So it's not necessary we will have 6 or 8, or I would not go precise distances, it's proprietary. But generally speaking, if you have long distance, cameras should be far apart. If you're looking for short distances, cameras should be closer. You always need central camera to integrate all together. And stereo never works. It's just not accurate enough. So there are other issues related to cameras, but fortunately, sensor technology moving very fast. Sony or STMicro made good progress of sensitivity, and also automotive cameras have better qualities than typical cell phone cameras. This is for the back, which requires accurate vertical, because you don't want to hit garage door when you're backing off. Now, current popular technologies. LiDAR is the king for now, and the reason for this is because they do very accurate depth measurements, very precise. But they have low resolution, typically VGA. They have low frame rate, under 20 frames per second. They are not working in fog or rain because laser beams not reflected from wet surfaces or scattered during the rain. And they're very expensive and power hungry. They cost, typical front LiDAR cost over $5,000. And they say they will be cheaper, but it's in the future. There are radar technology, which is not replaceable because they can work in all weather conditions. So if you have a snowstorm, nothing you can see, only radar will do. But they have even lower resolution than radar, and they do not really have object identification capability. You need supplemented by cameras or LiDARs or something else. Other solutions for camera structure light, but they have limited range. And stereo is just not good enough. That's why people have LiDAR. So what is our difference? So we have RGB at high resolution, at 60 frames per second. Remember, cars are moving fast. We have scalable depth range up to 16 bits. This is 60,000 different depths, which is much higher than typically people have 8-bit of 256 depths. And because of multiple cameras, we can produce under 1% accuracy at all distances. So we have optimized hardware, which is much faster than typical solution people have right now. And camera solution in general are cheaper, 10 times or more over LiDARs and radars. This is illustration how depth map matters. So that was the original image with a lot of texture details. And these are differences. 5 bits, you see straw head very small number of depths, and edges are not well defined. 8-bit typical active illumination, which is top-of-the-line cameras. And then 12-bit. We can do 16-bit, but in this simulation, I use 12-bit. Now, how we can work for NASA? So yesterday, I picked up the most sexy Mars or Moon vehicles, and please excuse me, I am not have any experience with this vehicle, so they just look good to me. And so what we actually can do? We do high resolution, and it could be HD or even 4K. We have a high frame rate, 60 hertz. We do pretty good accuracy, under 1% at any distance. We have efficient software. And I was mentioned that one of the main characteristics for all space vehicle is weight. So cameras weigh far less than LiDARs. And power consumption is also important. We talk about over 10x power consumption difference. And here is our team. That's me. I like to be in the front edge of technology. So that's why I moved from computer-aided design to computer graphics, been in a couple ray tracer company, image processing, and now I am interested in using this knowledge for real applications. SK Suzuki, he's actually in the audience right now, is a very distinctive person, and I'm glad to meet him. He is a business guy, but he also was CTO of Panasonic and worked at Sony and some other companies. Andrew Rossman, I worked with him for 5 years in Neomagic, and I think he's probably one of the best hardware engineers I've met. Andy has a distinguished career from having his company with flight simulator to designing chips, and embedded design chip for Neomagic was very important for their products. Also, he got to NetLogic and design was employee #1 and designed their product, and NetLogic was bought for $2.8 billion by Broadcom. Now, our advisors are Slava Kovsan. He is Bell Lab, was CTO of RSA, and then RSA was bought by Microsoft, and he ran 2 editions of Windows on security issues, and ended his career as advisor to Bill Gates. Dave Schreiner, he is a Silicon Graphics guy, one of the guru in computer graphics. He wrote multiple books, including OpenGL, OpenCL, and was head of SIGGRAPH for 2014. Paul Gallagher, he is ex-Samsung and Micron marketing guy. So what cluster image develop? Uniworking works in prototype. We design automotive prototype and have active discussion with leading automotive companies. So what we are looking for? Seeking for Series A and try to build world-class team and want to complete automotive prototype, robotic, and automotive has long certification process, so we need to worry about this. This is a brief schedule, how we get money. And just in summary, I would like to say that what we are doing, accurate object identification, and what we do, multiple cameras synchronized at 60 frames per second, have patented software, and precise computation at every depth. And this is provide for accuracy and performance for autonomous driving, security, and factory automation. Thank you.
Judges?
So I have a question over here, to your right.
Yes.
So
Thank you, sir.
sure. What are your spatial separation requirements for your camera clusters?
How to position camera within the set is proprietary.
I guess how far apart do they need to be in order to get the 1% accuracy?
It's very easily computed. Typically, very good binoculars, like 20, 30 centimeters, is far enough for these distances. But I will not give precise number. We did calculations.
What are the lighting requirements for the cameras? Do they work at night?
Yes.
Do they work at night? What sort of lighting do you need? How low light can they operate?
Very good question. So sensor companies like Sony increase lighting reception very much. And they work pretty well at daytime, like tunnels, very low light conditions require some IR source, like you put an IR in headlight. And also, I did not put in detail on this diagram that cameras could be monochrome without IR filter. So you have all multi-spectrum. And that will allow reasonable reception at night. So whatever you see, you can measure.
What would it take to increase the distance? You said you go up to 250 meters at the moment. Say you wanted a kilometer.
Well, automotive guys with Lidar talking about 200 meters. Nobody looking that far for automotive. For other purposes, it's possible. Especially, it's also distance between cameras and atmospheric issues.
Could you talk a little bit about business model? Are you looking to license this to the manufacturers, or where are you headed?
Well, so we internally had debate about this. So we're talking about licensing because it's faster money. But recently we talked to more than 2 venture guys. And they say there is no money in venture for licensing. They want product. And from our point of view, prices for automotive, this is one of the reasons we choose automotive, that Lidar costs $5,000. Bill of material for camera set is $200-300. So we can get a reasonably comfortable price and build a box. If big guys want to license, no problem. So we're ready to all deals. But now we are switching from licensing model to, at least initially, to building the boxes. Like you have a camera box, replace Lidar box. Very simple. 10 times cheaper and looks better. So we want to get on the dashboard of the car, our device, doing automotive prototype. That's why we need original, relatively small amount of money, and then by the end of the year, we want Series A money.
How resilient is the system over here?
Yes.
Sorry. So how resilient is this camera system to if one of the cameras breaks or turns off, or if there's grime on some of them, as someone who can't even keep her glasses clean?
Okay, good question. So first, there are several requirements, and one of them is thermal requirements. So you start in the morning and then go at high noon with 100-degree temperature. So you cannot use plastic. So it should be ceramic base. It should be very precisely positioned. And automotive cameras requires a lot of certification. So we are well in this process. So if cameras itself certifies, the box itself should be certified, and it's a process which typically done by tier 1 of manufacturers of the guy, and it's process. So for typical car, it's over a year certification. In terms of camera brakes, we think it should be in a dashboard, so it's covered with a glass, so dirt or something not important. But it's up to the automotive guys how to put it and how to really arrange, like on side. For example, they put it in a side mirror, and we think stereo, which people using right now, is not good enough. It should be at least 3 camera set.
Okay, but so if you have 6 cameras and 1 or 2 of them breaks, does the system still work, but more poorly, or does it stop working?
It will work not as good. It's still working, but accuracy of distance will be sacrificed.
Thank you.
Compromise, I would say.
How does it work in the fog? How does that noise, I'm over here. How does the noise affect it?
Yes.
So if you're in a fog and you're looking at it, so basically you're adding noise to the system. How does that affect your distances?
Accuracy will be affected. But basically, what you see is what you get. So if it's heavy fog, you need a radar. If it's light fog, you are okay. They're still better than LiDARs.
There are other camera navigation systems. How does this compare to them, and who's your competition?
Well, there are a number of stereo guys like Umbrella, which is doing pretty good stereo. But stereo is not competition to LiDAR. The resolution, image quality is not there. And I was having questions about Light, which is a big company, but they seems like move in different directions. They might deal with Nokia and some other big camera companies, and they are not that precise in computing depth. We are trying to do depth. That's what we do. We're not trying to zoom. We're not trying to do any fancy features. But what we're doing best. And I have patents for computer technology which does not require really fancy processors. So a regular good PC or Qualcomm processor will work.
So just to dumb it down for me, you're not making any cameras.
No.
This is all software. And the main differentiator for you, because you made a great case in your pitch for why computer vision is going to overtake LiDAR, which I think we're generally seeing as a trend, and Tesla's doing that trend and other things. But specifically for your solution, the difference is the ability to utilize multiple cameras to get better depth perception. Is that the differentiator between you and other camera-based solutions?
It's more than that. It's a system itself. So how many cameras, where to put them, how to calibrate them, what conditions need to be done to combine data together. It's not really simple things, because you need to do pretty accurate calibration, which is, you cannot get it from MATLAB.
Right, but that's the differentiator, is multiple cameras to get better depth perception.
Absolutely.
Okay.
How do changes in shade impact your accuracy? If you have a really sun-bright area and a very shaded area?
Automotive-grade cameras actually very good for handling this. For example, they have multi-exposure solutions. So every shot has multiple exposure, and they create a HDR image. Sony has even better. They do sensitivity of what they see and do measured exposure. But basically, multi-exposure produce high dynamic range, and that's allowed to do this.
Yeah,
Also, it's allowed to switch, like moving to tonal from bright to dark.
So you are using HDR or
Oh, yeah.
counted for?
We are talking about, yes, that's true.
Because those would be issues in space as well. And without atmosphere in a number of areas, we have extremes, and we have to tend to that.
Automotive-grade cameras are the best right now compared to cell phone cameras. They have much bigger pixels, so it's much better sensitivity. And I would move to automotive-grade camera in space. They're also good for vibration and temperature control and many other things which automotive requires.
Yeah, Simeon?
Yes?
Okay. So it seems that between all these cameras, it's a very computationally intensive problem that you're solving. Could you speak to that for a minute?
Yes. So if you do traditional vanilla computations, you need to compute parallax or difference between two cameras, or in our case with multiple cameras, for every possible depth for every pixel. So as soon as you start increasing number of depths, the computation linearly grow. And that's why top guys like Intel and Microsoft and some other go up to 8 bits. So 256 depths is what people can handle computationally. What I do is some proprietary refinement algorithm, which I will probably not discuss here. But that's starting from small number of depths and then do refinements. And I also use starting from low resolution to high resolution and refinement. Also, what we do is we are not using traditional graphical system because GPU is not good for image processing. We need everything in cache. We use all multiple processor, microcoded. And doing this, we can get reasonable results.
Thanks very much.
Thank you.